In this video, I will illustrate with an example how to resolve a limit indeterminate form of the type 0 times infinity. We cannot use L'Hopital's rule directly, but we can first rewrite the limit and then use L'Hopital's. This is the example. I want to compute the limit as x approaches infinity of x times 1 minus e to the 2 over x. I invite you to pause the video and try to compute it, or at least try to understand what the difficulty is. Then continue watching. This function is a product. Let's look at the two factors. The first one is easier. It has limit infinity. But what about the second? Well, as x approaches infinity, 2 over x will approach 0. And therefore, e to the 2 over x will approach 1. So the thing inside the brackets will have limit 1 minus 1, or in other words, 0. So I get infinity times 0. Don't be tempted to think this is 0. This is an indeterminate form. Remember, we are not actually computing exactly 0 times exactly infinity, which could make no sense. As x approaches infinity, I'm going to be multiplying very large numbers times very small numbers, and the result could be anything. This is a product. L'Hopital's rule only applies to quotients. Luckily, I can rewrite this as a quotient. What I did here is write x as 1 over x. If you simplify this nested fraction, you get back what I started with. Now that it is a quotient, let's see what type of indeterminate form. The numerator, as we said before, has limit 0. And the denominator, when x approaches infinity, has limit 0. Great! So it is a limit indeterminate form of the type when I can use L'Hopital. Perfect! And notice that this trick is going to work always. Whenever I have a 0 times infinity, I can rewrite it this way to get 0 over 0 or infinity over infinity. Because if a function has limit infinity, 1 over itself will have limit 0 and vice versa. Okay, let's go ahead and use L'Hopital's rule. I get the limit as x approaches infinity of, in the numerator, I take the derivative, which is minus e to the 2 over x times, chain rule, minus 2 over x squared. And in the denominator, I will simply get minus 1 over x squared. And conveniently, I can simplify this a little bit. And there, this limit is now easy to compute. I know the limit of the exponential part is 1, so the full limit is minus 2. Minus 2 is a number, so this use of L'Hopital was legal, and the original limit is minus 2.